I'm Adrian Bowles of Storm Insights. Just wrapped up the Innovation Day at the Watson School of Engineering and Applied Science at Binghamton University, where Storm is relocating, and was lucky enough to catch Katharine Frase, keynote speaker for the event and CTO for IBM's Public Sector Group, to get her thoughts on a range of issues from education to artificial intelligence. And I thought I'd share the highlights of that discussion, that interview with you in this short video. Thanks.
Theoretically, and I say it that way because no human can actually do all of this, I'm sort of the link between the research and development community of IBM and the sales teams for government, cities, education, healthcare, and life sciences. Which is, of course, impossible, and so I pick and choose. Yeah, and education is a place where I'm spending probably 2/3 of my time.
Really?
Yeah, so a number of years ago, we did a Global Technology Outlook topic on healthcare analytics, and could you change the effectiveness, not just the efficiency of healthcare with data and analytics and advice at point of care and supporting new business models. And about 18 months ago, we did a GTO topic that said the same things for education. When you look at digital content, one-to-one devices, are we now at a point where there's enough data to be able to affordably scale personalized intervention in a way that a teacher can actually absorb? And so building that out in some pilot projects and building that out in a way that IBM would actually be able to deliver at scale is where I'm spending a lot of my time. And a lot of it is K-12, and yet the cousin of it are all the same things that we see certainly in the community college system and to some degree in higher ed proper. These same issues around attraction, retention, results, placement. What do you do with the first generation learners? What do you do with the non-traditional learners? What do you do with education for returning vets? And there's a lot of work to be done. We spend so much time talking about big data, thinking about big data, talking about decision support and analytics and all that stuff. And often we remember to also talk about skills, but we often think about it as skills in what I might call a STEM context. We think it's skills in the context of science, technology, engineering, and math. And I think one of the things that I've begun to realize is that this big data thing is truly everywhere. That linguistics is as much about statistics as it is about languages anymore. That archaeology is data-driven. Everything is like this. And then I think about just what we all observe in our day-to-day lives. Every newspaper article has statistics in it. Everybody's got a probability of this or that, or an average of this or whatever. And my observation would be that a lot of people are not comfortable with those topics. And so where it takes me is a notion that, yes, we have to talk about data science and about curriculum and all that stuff, but we should also be thinking about something that I sometimes think of as numeracy. That just as years ago we didn't think engineers needed to take English, and then we discovered that everyone needs to communicate, that English majors should be taking math. Everybody needs to have an understanding about what these concepts mean so that they'll be comfortable with the dialogue that they're going to have to be part of, and that they can't be misled by somebody quoting some statistic at them and they're too uncomfortable to question it. So it's really driven to me a notion that the importance of math, and maybe it's not calculus, maybe it's statistics, right? But that math and comfort with numbers is going to be essential to the whole society. So I think there's some really difficult challenges ahead about curriculum, and I'll do it maybe in two buckets. So I think on this numeracy math bucket, I know that there's a lot of push now at K-12 to get to a more, I'll call it physically based understanding of math almost like the old Montessori methods where you, before you started working with numbers, you worked with objects, so you had a sense of volume and size and number. A greater reliance on estimation, right? You know, you see a lot of adults who don't realize that they've gotten the wrong answer on their calculator because they don't have an internal estimation engine running, right?
Yes.
Or you hear stories from lab assistants at college where kids will say, but that's what my calculator said. Well, you can't have 6 significant digits. I didn't give you 6, you know?
Yeah.
So I think some of those basic concepts around volume, size, the ability to estimate, right? And then I do think that some of the probability and statistics things. I think we spend a lot of time in our curricula on mathematics concepts that are really important if you're going to be a mathematician,
Right.
but perhaps not so much in everyday life. And I know that that's a real conversation, for example, in a lot of community colleges. What's the necessary math for someone who isn't there to transfer to a 4-year degree, but is there for a 2-year degree? What's the useful math for them to have? I think the other side of the equation is what are the, we had a conference a couple of weeks ago around something we called the T-shaped skills. It's something that Nick D'Onofrio and IBM started talking about years ago. And a number of universities have picked it up, this notion that when you go and survey employers and ask them what are the skills most missing in the kids you're hiring, interestingly, they seldom say that it is the deep technical skills that aren't enough. It's the broader skills around, have they learned how to learn? Have they learned critical thinking? Can they communicate? Can they both lead and participate in teams effectively? Some of the things that in engineering we sometimes think of as softer skills, but in many ways, if we think about it, they are the skills that differentiate people who are really successful in our companies and people who are not. So now the quandary becomes, what's the curriculum for a T-shaped person, and how do you fit it all in to an expectation of 4 or maybe 5 for engineering year programs, right? What aren't you going to do to give kids, particularly in engineering, hands-on skills, which they need in engineering, not just theoretical skills, and these broader skills, and whatever the expertise was that they're actually majoring in, right? And it's a real, I think it is a difficult problem, and I think we're still at the beginning stages of working through kind of what fits and what doesn't. I do think that a piece of the problem is that people are thinking that big data is only massive data, and it causes them then to not see the value that we're getting from the other complicated but small data pieces.
Yeah, it's relative in terms of
Yeah.
what's big data.
Yeah.
Great.
Great.
Thanks so
Adrian,
much
thank
for
you
helping.
very much.
Thank you.